Hey guys, I'm not going to do all the problems for this review packet, but I'm going to just go through a good handful of them. So let's just start at the top. It says identify the center and radius of the following equation. Also, I should mention this is the Unit 9 Honors Review packet. So remember, the center is always going to be the opposite of these signs. So my center is going to be at -4, +3. This is my radius squared. So if this is r squared, we take the square root. So my radius is the square root of 2. The equation of a circle given the following. So remember, we do x minus h, which is 12 squared. Then we're going to do y minus a minus 3, all squared. And then we're going to have 3 root 5 squared. Well, remember, 3 root 5 all squared is the same as 3 root 5 times 3 root 5. That's going to be 9 times the square root of 25, which is the same as 9 times 5, so that's 45. Okay, number 3, graph the following. My center is going to be a +3, -2. R squared is 25, so R will be 5. So I'm going to go to 3, down 2, and then I'm going to go 5, 5, 5, and 5. Okay, I'm not too worried that your circle is perfect, but I should be able to see these 4 points pretty clearly in the right place. Okay, I'll let you guys do this one by yourself. The big thing is, remember, since r squared is 8, r is the square root of 8, which is approximately, now I want to check, 2.8. So make sure when you're doing your radius, you're going out 2.8. Okay, I'm going to skip this vocab section because you guys can check the key. Let's look at number 6. Name the arc given by the given angle. So angle 3 is right here. So it wants us to name this arc. Well, this arc is going to be a minor arc, so I'm just going to use 2 letters. Let's call that arc ZY. Okay. Well, angle 8 is going to encompass this whole thing. So we're going to call this major arc GF. I use 3 letters because it's more than 180 degrees. Otherwise, we would think that GE was just this. Find the measure of the indicated central arc. So remember, if we have a central arc, the arc and the angle are the same. Remember, this is a diameter, or at least we know this one is for sure. So these two have to add up to 180. So that's going to leave me with 133 here, 133 here. So if I want the measure of arc TU, the measure of arc TU is going to be 47 degrees. Here we're at 80, 80, 100, 100. These are vertical angles. These have to add up to 180 if you go around. So IJ, that's going to be 100 degrees. Okay, let's go on to the next page. Find the perimeter of the triangle. Well, this is a tangent problem. You'll notice that these lines touch the circle only once. We call those tangent lines. And then whenever we have 2 tangents that meet outside the circle, this is like a party hat, right? So we've got party hat here, so these will be the same. These will be the same. These will be the same. So if this piece is 7.5, this piece here will be 7.5. Since this whole 0.7, if I take this away from this, I'm left with 7.2 here. That means this will also be 7.2. I take 7.2 away from the total, and I have 8 here, and I have 8 here. So my perimeter is going to be 14.7 plus 15.2 plus this whole thing, which is 15.5. So let me do that really fast. Number 9. Okay, these are going to be tangents, right? Because they're going to touch the circle just there and then keep going. Whenever a radius and a tangent meet, they form a 90-degree angle. So now I have a kite, because these will be the same. They're both radii. We've got the party hat theorem, so these will be the same. These 4 angles, because they're in a quadrilateral, have to add up to 360. So if I were to do 360 minus 75 minus 90 minus 90, I would be left with 105 degrees. Okay. Number 10, find the segment length indicated. Lines that appear to be tangent are tangent. Okay, well this is my tangent line, which means that this is going to meet at a 90-degree angle. Since this is 7.2, this will also be 7.2. We're just solving from here to here. Now you have a couple options for how to do this. You can set the problem up two ways. You can either say, okay, well 7.2 squared plus 15.4 squared is equal to this whole thing. So let's call this x plus 7.2 all squared. Another option for how to do this is say, okay, let's call this whole thing y. If I do that, I can say 7.2 squared plus 15.4 squared equals y squared. So if I do 7.2 squared plus 15.4 squared, I get 289. If I take the square root of both sides, I get y equals 17. Now, y is this whole thing. Since I've already used up 7.2, I'm left with 9.8 left for the question mark. So that's another way you could do it. If you solved it this way like we did in class, whenever you solve for x, that would just be that yellow portion. So x is the yellow, y was the green. Okay, number 11. Because this is a chord that's met at a 90-degree angle by something that goes through the center, these two will be the same. So if I solve for x, I'll also know y. So to solve for x, I do 12.4 squared plus x squared equals 21.1 squared. And you'll eventually solve for x, and whatever you get for x will also be the same for y. Okay, arc length. So arc length, remember, is angle over 360 times 2 pi r. It's a fraction of our total circumference, the total outside. Well, this bolded part here is 315 degrees. My radius is 18. So in my calculator, I'm literally just going to type in 315 divided by 360 times 2 times 18. And I get 31.5. I didn't type in my pi. Leave that at the end. 31.5 pi. That's leaving it in terms of pi. Sector area is a fraction of the total area. So in this case, it'll be 1/4 of my total area. I'm going to do 90 over 360 times 13 squared. And then leave my pi at the end. Okay, number 14, find the area of the shaded region. Okay, well the easiest way to do this is to start by finding the area of this whole thing. So I'll do area, so the shaded area is equal to the area of the cone or the sector minus the area of the triangle, because if I take away the area of the triangle, that will leave me with just that shaded region. Okay. So the area of the sector, sorry guys, 1 second. I'll finish this up in a minute.